Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 102 binary tree level order traversal. We're given the root of a binary tree and we need to return the level order traversal of its nodes values from left to right, level by level. So in this example we've got 3, 9, 20 and 15 and 7, so we return 3, and then for level 2 we return 9 and 20, and then our third sublist is 15 and 7. And we're given 2 more examples, and we're given some constraints as well. So how can we implement this problem? Well, the past couple of problems in this channel I've solved using something called DFS, or depth first search. But depth first search, as you can imagine, goes down the height of the tree. Breadth first search, we want to go horizontally. So not a vertical search, but a horizontal search, so we can get those values horizontally or in a level order. So breadth first search, also known as level order traversal. How can we implement this? Well, we can implement this with a queue, and it can be quite tricky to come up with if you've never come across breadth first search problems before. So I would recommend just memorizing the algorithm. But to do it, basically, let's just hop into the code, and it will make more sense than I think. So all our sublists need to be a single list, so that's going to be our result list. So we're just going to set that to an empty list, and then we're going to say we're going to set our queue equal to an empty list as well. And then we're going to say, actually no, it's not going to be empty list, it's going to have our root node inside. And we're going to say, while our queue is not empty, we're going to set our new sublist for the current level just equals to an empty list. And we're going to say for I in range of the length of our queue, let's get the node that we want to do some operations on. So that's going to be q dot pop 0. So why do we pop 0? Because normally popping in Python pops from the end of our list, and because we're using a queue, we want to be first in, first out, so we want to pop from the beginning of our list. We want to say if our node is not just a null value, we're going to say level dot append our node dot value, and then we're just going to say we're going to append to our queue node dot left, and we're also going to append node dot right. Now, if all the values in our list were just null nodes, then our level list would be empty. So we want to check if our level list is actually not empty. And if it's not, then we're going to say result.append and our current level. So now we've got our result list done. Let's return our result list. Let's run the code and see if it works. It does. Let's submit our code, make sure we pass all test cases. And we do, and we have an optimal solution. So again, a bit tricky to come up with, but this is the essence of breadth first search. And in terms of time complexity, we're looking at O of n time complexity, and space complexity is also going to be at O of n because we are using the queue to store all the values for our binary tree, in which basically in worst case could be n divided by 2. So we basically just round that up to n. So our time complexity is going to be O of n, and space complexity is going to be O of n as well. So I hope you guys enjoyed this video, and I'll catch you in the next one.